Power amplifier. Today's topic is power amplifier, how it's different from the ordinary amplifier. And we know that in case of the power amplifier, we need the appreciable output. And to get the great output, the input signal should be also large. We consider that NPN transistor emitter grounded and base is the input. Input signal is given to the base and output is taken at the collector. The current flowing through the collector is IC, through base is IB. That resistance is R dash. This current is IC and IP. VB and IC. VB is input parameter, IC is the output parameter. When one parameter is input side, and second parameter of the output side, the graph between the two parameters is called then transfer curve. This transfer curve becomes dynamic when we give AC signal to the base. This is a straight line, the graph between VB and IC, but it is straight line for some extent. Up to some extent it is a straight line. When AC signal is applied, the curve is called dynamic. Dynamic transfer curve. We classify the operation into the three classes, class A, class B and class C. First of all, coming to class A. So this is a dynamic transfer curve. It's a straight line. So we have chosen the middle point of it. The middle point is called the Q point, that is the operating point, quiescent point. And for Q point, the voltage is VB, and for Q point, the collector current flowing is IC, the capital letters both. Let the input signal swings. With that, the base voltage varies between the two limits, between these two limits, like the tone, the lines. The base voltage is varying between the two. Thereby, the collector current also varies. The line shown, the variation of the collector current. So this is the collector current which is varying. If base voltage goes up, the collector current too. And if the base voltage goes down, collector current also. In the same way, as the base voltage is varying, in the same way the collector current is varying. The base voltage is varying A to B, B to C and all, and collector current is varying D to E and E to F, like that. So for power amplifier, we know that the input signal is large, but there is a problem. The input signal, it covers most of the part of this transfer curve, and when it covers most part of the transfer curve, then because the transfer curve is linear at the middle, but it is somewhat not linear, for lower and upper part. So with the result, what happens, if we give input signal, it will not be reproduction of the faithful reproduction of the output signal. If the graph, if it is the signal is large and the transfer curve is not exactly a straight line, then the output signal will be distorted. So input signal and output signal is proportional to output signal is exactly of the same shape that of the input signal. It is amplified, but the shape wise it should be the same that of the input signal, but it happens Now, what is the solution of this? As the output is distorted, if the input signal is large, the solution is we should use the push-pull method and negative feedback. In order to get the exactly faithful reproduction of the output signal. Okay. Now it is important for the class A operation, Q point should be placed near the center of the line, center of the linear region of the dynamic transfer curve. This is the most important condition for the class A operation, that the Q point should be exactly at the middle of the transfer curve. With that, for this operation, distortion is low for small signals, number one. Number two, efficiency of the conversion of DC power supply to AC signals, AC signal power output is also very low. So this method is not preferred practically because of the efficiency, low efficiency. Now we coming the class B operation. So Q point is not at the origin, it is just close to origin. The graph is again a straight line between VC and IC, between VP and IC. So input signal is coming and it is varying across the Q point. It is varying across the Q point. Input signal, as the input signal varies, exactly in the same way the base voltage varies. But you know, some part of the base voltage will not respond to the collector current because Q point is just near the cutoff. So we see that how much part of the base signal converted to the collector current. So like this, only the positive half in some part is clipped, but most of the part appears. Most of the positive part converted into the collector current, and similarly when the next cycle comes, the positive part of that cycle also converted to the collector current. So only positive cycle converted into the collector current. This is very important for the class B operation. Q point is set here near the cut off to allow greater power output. So now what happens for this operation? Most of the linear region of the dynamic curve becomes available for the conversion. With that, the power efficiency increases and larger input signals are possible because most of the linear region becomes available for the variation of collector current, as that most of the portion of the dynamic curves handles only the positive part of the signal. So larger input signals are possible. The negative half, one half, converted to the collector current, but the other part of the signal, no output, because it drives the transistor below cutoff. And therefore, even order distortion becomes high. So in class B operation, even order distortion becomes high. Now what is the solution? So this is a solution of this problem. we should handle the other half of the wave for the second transistor by the second transistor. One transistor handle one part of the wave, other transistor will handle the second part of the wave. That is called push-pull amplifier or complementary circuit. So with that, even harmonic distortion will also get eliminated and cancelled out. Okay, and useful output power will be available. So this is very important, that what is the purpose of the push-pull amplifier. So it is clear from class B operation. Now we are coming to the class C operation. Here the Q point is just far away from the cutoff. Base voltage and collector current. The input signal is again varying like this. With that the base voltage varies, but only a very small part. So this is the dynamic curve. Now only a very small part, you look here, only a very small part converted to the collector current. So only this part of the input signal. So in class C operation, Q point bias is well beyond cutoff and conduction occur for less than half of the input signal. The distortion is very high for class C operation because there is only part of the input signal is converted, but the power conversion efficiency can be theoretically reach 100%, not practically. So this is class C operation. Now what is the conclusion? The conclusion is class A and class B is oftenly used for audio frequencies. Audio frequencies are less frequencies. Class B and class C amplifier are employed for higher conversion efficiencies with greater power, with greater efficiencies in the generation of the large amounts of radio frequency signal.